Fill your ice cube trays with water, place them in the freezer, and the next day you will have ice cubes formed through a process called freezing. If you drop those ice cubes on the floor, soon they will have melted into a puddle of water. Freezing and melting are two common phase transitions or changes in the states of matter to or from solid, liquid, gas, or plasma. Sublimation is another one of these phase transitions, except in this case, we have a solid turning directly into a gas. As a sublimating material changes from a solid to a gas, it never passes through the liquid state. This image shows water in its three forms: ice, water, and steam. Sublimation is just one of the ways water or another substance can change between its potential phases. Substances such as water and carbon dioxide, CO2, can be charted on a pressure versus temperature plot to reveal their state of matter, solid, liquid, or gas, at a given temperature and pressure. At a typical atmospheric pressure, we know that water is a solid at temperatures below 0 degrees Celsius, a liquid from 0 to 100 degrees Celsius, and a gas at higher temperatures. Atmospheric pressure, however, can change, particularly with altitude. Higher altitudes yield lower atmospheric pressures. As shown on this graph, we can experimentally observe that water doesn't always change phase at the same temperatures. For instance, with lower pressures, liquid water changes to a gas at temperatures lower than 100 degrees Celsius. If the pressure is dropped low enough, water reaches what's known as a triple point, the pressure and temperature at which a substance can exist in solid, liquid, and gaseous forms. Below the triple point, solid water sublimates, changing directly into a gas with the temperature increase and never passing through the liquid phase. CO2 has a triple point at a pressure higher than 1 atmospheric pressure, meaning that at Earth's standard atmospheric pressure, CO2 will sublimate as it heats from a solid to a gas. Found in witches' cauldrons at Halloween parties, solid CO2, also known as dry ice, sublimates at typical atmospheric pressures and temperatures on Earth. Its cold temperature as a solid makes it an ideal coolant, but also makes gloves a requirement for sublimation experimentation. Although we typically think of water changing from ice to liquid to gas with increased energy, it is possible for ice to sublimate. This process is most obvious in freezing, dry climates at high altitudes, where there is lower atmospheric pressure. In this photo, we can see blades of ice with hollows where the ice has sublimated. Sublimation is a type of phase transition, or a change in a state of matter, just like melting, freezing, and evaporation. Through sublimation, a substance changes from a solid to a gas without ever passing through a liquid phase. Dry ice, solid CO2, provides a common example of sublimation. It is also possible for ice to sublimate, though it requires specific weather environments and high altitudes.